Welcome back. Today I'm going to be going over this SAT question, right, which is in the category of statistics, right, and data analysis. So, once again, I don't want to waste any more of your time, so let's get right into it. So, here we have two data sets. Set A consists of 12 values and has a mean of m and a standard deviation of s. So, right away, we probably have to know what mean and standard deviation are, right? And it tells us two of the values in the data set are 4 and 22. Okay, so those are the only values we know. Dataset B is created by replacing those two values with 10 and 16. So the only difference between A and B is that B contains 10 and 16 instead of 4 and 22. And now we have to compare the mean and standard deviation of the two sets. So right away, right, let's first focus on, like we know we have to compare two distinct values here, right, the mean and standard deviation. Let's focus on the mean first. So mean, right, just as a reminder, is the average value in the data set. And one way you can represent this is the sum of values, right, in the data set over the number of values. So in this case, let's look at set A first, right? So data set A consists of 12 values, right? So you know that on the bottom here, the number of values is 12. And we also know that two of the values are 4 and 22. Well, how do you find the sum of the values, right? We only know 4 and 22. What about the other 10 values in the data set? Well, you can't find the sum, right? Exactly with those because we don't know what those 10 values are, but we can still find a way to represent it, right? So we know two of the values are 4 and 22, and we don't know the other 10 values, right? We don't know the how much they add to the data set. So let's just call that x, right? Or actually, let's just call that plus the sum of other 10 values, right? Again, we don't know what those are because we don't know the values themselves. So together, this is going to make up the sum, right? So 4 and 22, if you add those two, you get 26. So you add 26. And of course, the sum of these 10 values, I'll just write that as sum of 10 values. So that's the mean of the first data set, right? Data set A. Now compare that to B, right? Again, the only difference is that you're replacing those two numbers with 10 and 16. So for dataset B, right, it still has 12 numbers, right, because you're just replacing them. So it still has 12 terms or 12 values. Think about what we know now. Instead of 4 and 22, we have 10 and 16, right? So we have 10 and 16. And once again, we don't know the sum of other 10 values, right? So we're just going to call that, right? Now the key thing to realize though is that the only difference between these two data sets are these two values, right? 10 and 16. Um, the other 10 values are the same, right? Like those don't change. So we know that those 10 values have to add up to the same sum. So again, right, because you have to add all this up when you're trying to find the mean, well, what's 10 and 16 equal to, right? 10 plus 16 is 26. And of course, we have to add the sum of those 10 values. And that equals the mean of dataset B. And this is the mean of dataset A. You'll notice here that A and B actually have the same mean, right? It doesn't change because you're dividing by the same number of values, right? Um, and the sum of the two numbers that we know, right? Of course, the numbers are different, but when you add them together, right? 4 and 22 give you 26, and 10 and 16 also give you 26. So that doesn't change either. And of course, I told you earlier that the sum of these other 10 values doesn't change either, right? Because we're not replacing those values. So actually, the mean of both data sets are the same. So using that information, we can cross out A and B, right? Because the mean is not greater or less, they're the same. Okay, so now that we know the mean is the same exact value, let's find the standard deviation. Just as a reminder, right? Standard deviation, that's a measure of how much a data set varies, right? How much it um, varies in general, right? You should know that a greater standard deviation has more variance, right? And then a lesser standard deviation has less variance. What do I mean by variance? Well, just how spread a data set is, right? So, like, for example, you might have a data set where the numbers are 1, 2, 3, 4, and 5, right? And if you compare that to like a data set with only ones, of course, the data set with only ones has less variance, right? Because, well, frankly, all of them are the same number, right? Whereas this data set, it's more spread out, right? It has more different numbers. So that's why this one would have lower standard deviation, right? Because it has less variance. So how can you apply that logic to this problem? Well, you know, again, you know the mean is the same, right? Look at what's changing. So the 4 and 22 are being replaced with 10 and 16. Now, the key thing to realize, right, is, well, of course, you know that standard deviation has to do with how spread apart the data is. 4 and 22 are further away from like the middle ground compared to 10 and 16, right? One way you can think of that is if you represent these values on a number line, right? And let's call this a center, or like the middle ground, right? 4 and 22 might be here, but 10 and 16 are closer to the middle, right? Because they're closer to the middle, they are not as spread out as compared to these values. Because they're more spiked together, right? Um, they're located in a more specific center rather than being spread out. Those actually decrease their standard deviation, right? Because there's less variance, right? Another way to think about it is the data set here only kind of lies in the middle, right? Whereas if you had 4 and 22, it would be spread out more, right? So again, if you replace those two values with 10 and 16, you're decreasing how much this data set varies. So therefore, the standard deviation is decreasing, right? So of course, that matches with our answer choice here, C, right? Where the standard deviation is less. So what are the key takeaways? Well, for mean, right, it doesn't matter if the values are different, right, themselves, but if they add up to the same um, number, then the mean doesn't change, right? Because for mean, you only care about the sum of the values. For standard deviation, uh, it's a measure of how spread apart something is, right? So anytime you replace values with ones that are closer to the center, right, um, or like closer in general to the middle ground, where right, you're going to decrease the variance, right, because it's less spread apart. So hopefully this problem made sense. If you have any questions, leave it down in the comments, and I'll see you next time.